how exponential functions happen in the real world all the time. They're all around us. We talked about how you can have bank accounts that grow exponentially, or when you invest in the stock market, or coronavirus, or other types of viruses or bacteria. There's a lot of real world examples for exponential functions. So what we're going to do today is we're going to see how you can have a real world example and turn it into a function. How can we write it into a function? So we kind of did this at the end of class yesterday, but I do want to review it one more time because we're going to need to use it today, converting percents into decimals and back and forth. So I'm not going to do as many examples as yesterday, but I'll just do a few. So first thing is we're going to go from a decimal, to a percent. I'll just do 3 examples. First one. Second one, just go ahead and write these down. And number 3. Okay. So go ahead, just write these down, and then we'll just quickly do them all together. Oh my goodness, let me try to move them over so I have more space. There we go. Okay. What is 0.23 as a percent?
23%.
23%. We take that decimal 2 steps to the right. 23%. What's 0.02 as a percentage?
Well, what was the question again? I'm sorry.
That's okay. Just on number 2, what is 0.02 as a percentage?
2%.
2%. Same thing. We're just moving that decimal 2 steps to the right. So I get 2%. 0.123 as a percentage.
12.3%.
12.3%. Same thing. 2 units to the right. So my decimal is between my 2 and my 3. 12.3%. Any questions on turning a decimal into a percentage?
Question not related to the topic.
Sure, go ahead.
Are we able to use a notebook that a spiral notebook?
Yes, absolutely. You can use whatever notebook is best for you. I don't really mind. In fact, the composition notebooks, usually they're just not big enough for this class because you always end up running out of room at the end. Okay, now percent to decimal, we're going backwards. So here we go. Let me think of a good one. All right. 45% as a decimal?
0.45.
Good, go backwards this time. 0.45. 7%.
0.07.
0.07. So be careful with when you have a 1-digit percentage, we always end up putting a 0 in front because you got to move that decimal 2 steps to the left. You have a blank space, you're going to fill it with a 0. And 12.5%?
0.0125.
Careful. Try that again.
Oh, I'm sorry. I added an extra 0. 0.125.
0.125. Good. Okay. Any questions on going from a decimal to a percent or a percent back to a decimal? Okay, good. One last thing I want to do now It's just a little bit of math with decimals. Shouldn't be too bad, but let's just see what happens. Okay, what is 1 plus 0.12? That's the first one. What is 1 minus 0.12? And finally, what is 1 plus, let me do a good one. Let me think about it. 1 plus 26%. So, thank you, Juan. The first one, 1 plus 0.12, that's 1.12. We just add that together. Now, what would be 1 minus 0.12?
0.88.
0.88, good. One way that I like to do these types of problems, if you're adding or subtracting from 1, when you subtract from 1, think about it like money. So it's $1 minus 12 cents. Or another way you can think about it is, if this helps you, what's 100 minus 12? That's 88. So then you turn that back into a decimal. Now, what about this last one? 1 plus 26%. Can I just add a percentage like that?
No, you're gonna have to do what Miss Sneed does. It's hard when she does it.
What does she do?
I believe I think I remember. She does she puts the percentage on the top. I don't know how to hold on. May I please annotate?
You may, but I'm gonna make your life 10,000 times easier.
You could just put a 0 in front of the 26.
Put a 0 in front of the 26. In other words, what are you turning the 26% into?
A decimal.
A decimal, yeah. So this is the same as 1. Let me write it in blue. This is the same as 1 plus 0.26. Because you can't just add a percentage like that. Percents are not real type of numbers. A percentage is just a way to rewrite a decimal. So if you want to add a percentage to something, you have to add it by turning it into a decimal first. And now what do I have? What's 1 plus 0.26?
1.26.
1.26.
I think I was explaining a different strategy. I'm sorry.
Yeah, that's okay. That's okay. I know that with percents, there's like 20 different things you can do, and sometimes you forget what you're actually doing. Alrighty, so any questions on that? Okay, so now we can go ahead and get started. So what we're gonna do is, I'm kind of expanding the standard form of exponential functions just a little bit. I'm kind of adding something to it. So take a look at this new way of writing exponential functions. This is called exponential growth. This is an exponential growth function. And you'll see why in just a moment. But basically, let's go ahead and write down the exponential growth form. And then I'm going to just label everything. So A is still A. A is still the y-intercept. But since we're talking about the real world now, what does the y-intercept always stand for in the real world? So when you're reading a real world problem, how do you figure out which of those numbers is the y-intercept?
The starting point?
You got it. Good. The y-intercept is the starting point. And then since in this chapter we're mostly talking about money or like the amount of things, we're just going to write the starting amount. Starting amount. So A is still A, but now it has a meaning. It's the starting amount. Now R is the growth rate. Still the growth rate. But what's important about the growth rate is that you're going to see a percentage and you're going to want to turn it into a decimal. Because of what we just said, you can't add a percentage to the number 1. You have to turn it into a decimal first. So the growth rate is the percentage turned into a decimal. And now we don't really use x anymore. We're going to start using t because usually with these problems, we're talking about time. So our input value is always going to be time. So go ahead and just go and write down the exponential growth formula and label it just like I did. And then in about 30 seconds, we'll start with example number 1. I just realized that I copied down the wrong sentence here.
We're copying down the example?
Yes, except that I made a mistake, so let me fix it and then you can. Okay, so where I crossed it out, this is what it's supposed to say. So can anybody read for us example number 1? Who would like to read? Someone I haven't heard from yet. Someone I haven't heard from yet. Who can volunteer to read?
Miss, I have a question about the expression.
Sure.
What does the T mean? Like both the T's?
Both of them are time. So it's always going to be time, and it might be hours, years, minutes, whatever the problem you're looking at says, that's what that variable is going to be.
Okay. Thank
Okay,
you.
so we'll see it in this. It'll make a little bit more sense in just a moment. All right, who can read? Who's going to read?
A painting is sold for $1,800 and its value increases by 11% each year after it is sold. Write a function that represents the value of the painting after T years. Then determine the value of the painting after 30 years.
Perfect. Okay. So what I'm going to do first, I'm going to highlight my information and we're going to match it to the right variable. So what would be my growth rate in this example?
11%.
11%. Good. 11% each year. My starting amount?
1,800.
Good. Okay. And I'm going to pause there because what we're going to do first is we're going to write the function. And remember that when you write a function in its most basic form, the variable, usually it's x, but this time it's t. The variable, we're not going to put a number there yet. You only put a number there when you're being asked to do so. So first thing, I'm just going to write the function and I'm going to leave just t as it is. And then after that, I'll plug in my input value. So for now, we're leaving the t exactly where it is. We're not changing the value. So my function is going to be f of t equals 18,000 or 1,800, 1,800, parentheses, 1 plus, okay, I have 11%, but remember it has to be turned into a decimal. So what is 11% as a decimal?
In 1100s.
Good, 0.11, exactly. So now I'm gonna write it in just like that, 0.11 to the power of t. Like I said, I'm just leaving t as t. We're not changing its value quite yet. We'll do that in just a moment. Because before I can do that, I'm just going to simplify this a little bit because I can actually go ahead and add 1 plus 0.11. So my final simplified function, f of t equals 1800 times 1.11 to the power of t. There it is. So it's not too bad. It really, you just got to pick out those numbers from the sentence, from the example, and put them into your function. Any questions so far? Cool. Okay, now I'm going to go to that last sentence and reread it because it says, then determine the value of the painting after 30 years. So now what I can do is 30 is my time, my amount of time, that is my input value. So what I can do is I can evaluate this function by plugging in 30. So I'm finding f of 30. Let me make this a little bit smaller because it is in my way. There we go. So 1800 parentheses 1.11 to the power of 30. Now this is where that calculator is going to come in handy. And if you remember from the other day, I showed you guys how to bring something to the power of any number. Would anyone like me to show you one more time how to do that on your calculators?
Yes.
Yeah? Okay. Let me share my phone screen. Hold on one second.
What does E mean?
E, I'll explain in a second because that might happen to me as well.
Yeah, because I have, you'll see.
Okay, so here's my calculator. Cool. I'm doing 1.11 to the power of 30. So there's a button. Let me show you which button it is. There's a button that actually, can anybody annotate on the screen and circle the button that I'm going to be using to bring it to the power of 30? Good, Jara, good. So that's my button. So I'm going to do 1.11. Then I'm going to hit that button, the x to the power of y button. And then after you hit that button, oh, it's taking its sweet time. Sometimes, sometimes my phone just doesn't connect very well, so it's going a little bit slowly. So I'll just wait for it to go. There we go. 1.11. Then you hit the XY button. And after you hit the XY button, you can hit 30 and then hit enter. So I'm just waiting for it to load. Oops. Okay, there's the XY button. Ooh.
Miss, why didn't we multiply 1,801.11 first?
Can anybody remind me what PEMDAS tells me to do first?
Parentheses.
And then after that?
Exponent.
Exponent. That's why. Because following PEMDAS, you have to do the exponent first. So that's what I just did. So I did 1.11 to the power of 30. Then I'm not going to clear my screen. I'm going to leave that number there because now all I need to do is multiply that times 1800. And it's taking it's taking a second, but you'll see what we get in the end. Now, do I have any questions on how to do this on your calculator? Do I have any guesses before it comes up on my screen? If you haven't done it yet, I started at $1,800. How much do you think it's going to be after 30 years? If you already know the answer, don't say it.
Oh, okay.
What's a good guess? Think above $1 million or below $1 million?
Oh no.
Oh, it stopped sharing. Okay, well, I tried. My phone just doesn't really like to connect very well, unfortunately. But I will, oh, there it goes. Oh, okay, there you go. There's my answer, $41,206.13. So that's how much my painting is going to be worth after 30 years. So it's below $1 million. And that's because the growth rate is kind of low, right? 11% is not really that much at the end of the day. So it is exponential, but it's going to take a really long time before that number gets really, really big. So f of 30 is $41,206.13. All right, so questions, any questions so far on how to write the function or how to evaluate the function? Cool, let's do a couple more examples. I have 3 on here. So what I want you guys to do is actually try these on your own. I think you guys are already ready to do so. Just remember to, what do I do to my percents?
Cents, turn them into decimals.
Turn them into decimals. And in these 3 examples, you are not evaluating the function. You're just going to write the function as it is, keep the t as a t. We're not plugging anything in just for these 3 examples. So this is just writing the function. Go ahead and take about 3 minutes to do so. Good, nice, Lauren. Okay, take about 30 more seconds. Alrighty, so I'll start off with example number 1. If you have answers, you are free to send them to me in the chat. But first of all, with example number 1, this percentage here, what is 6% as a decimal?
Oh, I added, wait.
0.06.
0.6. 0.06.
0.06, good.
I don't know why I keep on adding extra zeros.
Yeah, be very careful. Percents and decimals, just one way that I think about it a lot of times is like money. So like think about how 6 cents is written like this when you're talking about dollars, right? So 6 cents is $0.06. That's another way to think about it. Okay, so that's my percentage. Now I go ahead and I plug everything in. So I have f of t equals 24,000, parentheses 1 plus 0.06 to the power of t. But we always want to simplify that parentheses right away. So my final answer when I add that is going to be f of t equals 24,000, parentheses 1.06 to the power of t. Okay, any questions on number 1? Cool. Okay, number 2, what is this percentage as a decimal?
0.018.
Good, 0.018.
Oh, I messed up there then. Oh no.
It's okay, we're learning, that's okay. If you want to just take it real slow, you always can make sure you're bringing that decimal point 2 spaces to the left.
It's sort of weird because I know how to say it, but when I type it, I just put something random.
Okay, so that's what we're going to work on, okay? Because it does matter, especially on the EOC, there's sometimes you actually have to write it out instead of it being multiple choice. So you got to be very careful. So f of t, my bad, I wrote x. F of t equals 55,000, parentheses 1 plus 0.018 to the power of t. When we add that together, we get f of t equals 55,000, parentheses 1.018 to the power of t. Questions on number 2? Cool. All right, last one, number 3. What is 3.1% as a decimal?
0.031.
Good. 0.031. So f of t equals 300 times 1 plus 0.031 to the power of t. And that's 300 times 1.031 to the power of t. Okay. What's something that all 3 of these have in common? What was inside of the parentheses? Each of those numbers always starts with a 1. And that's going to be when you're looking at a problem and you're thinking, okay, is this growth or is it decay? What do you guys think is happening here? Well, you can actually read it off of the problem, but is this growth or decay for all 3 of them?
Decay.
Okay, read the word problem. Where do we see a key word?
Oh no, it's growth because of increased and gains.
Good. It's increasing, gaining. Okay, so all 3 of these are growth functions. And the way to know if something is growing is when the rate is greater than 1. So inside of my parentheses, all of these numbers are greater than 1. 1.06, 1.018, 1.031. Even if it's not that much greater than 1, they're still greater than 1. So that's how you always know if you have a growth function. Okay, any questions on that? Cool. Any final questions on this page? Awesome. All right. Well, now let's talk about decay. Take a look at my decay form. Does anything change? What's different?
It subtracts.
It subtracts. It's exactly the same in every other way, but this time I'm taking away from one. So this is still my starting amount. R is still my percentage turned into a decimal. And T is still time. It's all exactly the same. Only difference is that we're now subtracting, which makes sense, right? Because if I'm decaying, then when I subtract something from 1, that number is going to be less than 1. So let's take a look at our example here and see how this is going to look a little bit different. So can I get a volunteer to read example 1 for us? You can go ahead and read. On this beautiful Friday, y'all. It is, well, it's not that beautiful outside, but who can read? It's Friday. We're almost done.
I will read, but you said you wanted someone new.
Yeah, I want someone else. No offense, Jaira, but you know, you're always participating. Who's feeling up for it?
The amount of certain radioactive substance decreases by 15% every hour. If a sample starts with 100 grams of the radioactive substance, write a function that represents the amount of radioactive substance left after X hours. Then determine the amount of radioactive substance left after 5 hours.
Perfect. So, same as before, we're just going to write the function, then we'll plug in our input value. So for now, I'm just going to start by writing my function. My starting amount is 100 grams. My percentage is 15% every hour. So what is 15% as a decimal?
0.15.
Good. Cool. Here we go. F of t equals 100 times 1 minus 0.15 to the power of t. So here's where we got to be very careful, because what is 1 minus 0.15?
Um, 0.8.
0. You're almost there.
0.85.
Yeah, 0.85. 0.85. Think about it. $1 minus 15 cents is 85 cents. So we have 0.85. So what's different about this function? What's inside of the parentheses?
Inside the parentheses.
We subtracted instead of adding.
Right.
Lower than 1.
Right. So the number ends up being less than 1. And that's how you can always tell when you have exponential decay. So the rate inside of those parentheses is going to be a decimal less than 1, 0 point something. Okay, so there's our function. Now let's see. It says find the amount of radioactive substance left after 5 hours. So we're going to plug in 5. And again, remember, when you're plugging this into your calculator, you have to do the exponent first. So we're doing 0.85 to the power of 5. Leave the answer on your screen and multiply it by 100. So take a moment, see what you get. Good, I'm seeing some answers in the chat. Go ahead and give me your answer to the nearest hundredth. Nearest hundredth. All right, so on my calculator, I end up with 44.3705. So to the nearest hundredth, what would be my final answer?
44 and 37 hundredths.
Good, 44.37. So that's my hundredths place. The number that comes next is a 0, so I'm going to leave it as 44.37. It does not round up. Cool. Any questions on this problem so far? That's grams. Okay. What was my percentage rate? My percentage rate?
15%.
15%. So this is something that we're going to be very careful with. The percentage is 15%. In the parentheses, however, I see 85. So whenever you notice that you have a decay function, because it starts with a 0, and the question asks you what is the percentage of decay, you have to think about what number was taken away from 1. Which number did you take away from 1 in order to get 85? In order to get 0.85?
0.15.
Exactly, right? So I'll show you guys that in a couple of slides, but that's just something that we're going to keep in mind. So here we go, a couple more. Same idea as before, take about 3 minutes to write each of these functions. We're not evaluating them, we're just writing down the function itself. But make sure that you do simplify inside of those parentheses. Alrighty, couple seconds remaining. Okay, and example number 1, let's start by converting the percentage. What's 3% in decimal form?
0.03.
0.03. So here we go. So now I've got f of t equals 280 times 1 minus 0.03 to the power of t. So what ends up being in my parentheses when I subtract? What's 1 minus 0.03?
0.97.
0.97, good. And remember, you always want to make sure you do that. I don't want you to leave it as 1 minus 0.03. Your final answer should be completely simplified inside of the parentheses, okay? So it's not wrong technically if you didn't simplify it, but for my purposes and for this class, we're always going to simplify. So any questions on number 1? Awesome, awesome. Number 2, 8% as a decimal?
0.08.
0.08. So I have f of t equals 7,800 times 1 minus 0.08 to the power of t. My final answer is 7,800 times what?
0.992.
Good, 0.92 to the power of t. Okay. Finally, who can give me this last one in the most simplified form? So the final answer for example number 3. Anyone? The final answer.
T would be 1, right? Because per year.
T is t. T is t. We're not changing the value of our t. So just the final function, just like the last 2 examples.
60, 100,
Mm-hmm.
then 1 minus 0.03.
Okay, but the final. So that's,
Oh,
so what am I boxing?
Oh,
0.97.
97, yeah.
Good. To the power of t. Cool. All right, so remember, like kind of like with growth functions, always have a number more than 1, greater than 1. For decay functions, the rate inside of those parentheses is less than 1. So you're always going to see a decimal that starts with 0. All right, any questions on these 3 examples? Cool. Okay, here's a couple of more what you might see on a test. So go ahead and take a look. Let's start with just example number 1. Just example number 1. And I want to do this as a poll. So go ahead and I'll start reading. I'll read number 1 and then go ahead and answer it as best as you can. So Genevieve deposited $400 into her bank account. The equation A of t equals 400 times 1.07 to the power of t can be used to calculate the value of her money after t years. What is the annual interest rate she is earning on her deposit? So we're looking for the interest rate. And my one clue with this is don't overthink it. Don't overthink it. Okay. 10 seconds remaining. 10, 9, 8, 7, 6. Only half of the people here have answered. I want an answer from everybody. Go with your gut. It's completely anonymous. I do not know who chose what answer. So I'm still missing 7 people. Let's go, guys. Put your answers in the chat, in the poll. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, I'm a little disappointed, to be completely honest, that I only had 8 responses. That's not how this works, you guys. If I put a poll up, you answer it. You don't just leave it blank.
Sorry, I lagged
Okay, because as your teacher, I need to know
out.
how everybody's doing in order
Lagged out.
to help.
School.
So if you did not answer it, you're not helping me. But 8 people voted, so I appreciate those who did. Here's the results. C and D were the most popular 2 answers. But let's be very clear. It's asking me for the interest rate. It's asking me for the percentage. It's asking me for the percentage because look at all the answer choices. All of the answer choices are percentages. So let me go back a couple slides. Look at example number 1. What was the rate in example number 1?
6%.
6%. When you actually write the
I
function
actually
though,
chose D. I meant to choose C.
okay, David, okay. If my rate was 6%, my function says 1.06. When my rate was 1.8%, my function showed me 1.018. So the rate is not what you see in the function. The rate is what was added to 1. So let me go back. So let me rewrite this function because I have a of t equals 400 times 1.07 to the power of t. But we know that this was simplified because we always simplify it in the last step. So working backwards, kind of working backwards, before this function was simplified, it would have said 400 parentheses 1 plus 0.7 to the power of t.
Means 0.07.
This is my growth rate, but that's my interest rate as a decimal. So what is 0.7? 0.07, my bad. Let me rewrite that, hold on. 0.07. What is 0.07 as a percentage?
7%.
7%. That was the original percentage. So whenever it asks you what is the percentage, you have to work your way backwards in order to figure it out. Because just by looking at the function, that's giving you false information. This is not the growth, this is not the percentage, okay? That's what you get after you simplify. So you always got to work your way backwards and think about, okay, what did I add to 1 or what did I subtract from 1 in order to get that answer? So try it again. That's okay, we're learning. So try it again with example 2. Same idea, here's your poll. And let's see if we can do a little bit better this time. And I would like more participation. More participation, because I keep these polls anonymous because I don't want you guys to think that I'm judging what you answer. But if I don't have a lot of participation, I'm going to have to make it not anonymous. So I will see who answered and who did not. So don't make that happen for yourselves. If you want to remain anonymous, then I need everybody to participate this time around. Alrighty, I'm gonna give you guys 30 more seconds. I have 8 answers out of 16 students. I'm still missing half of you. And if I don't get the majority, then I'm gonna have to turn off the anonymous function, and I'm gonna be able to see who is answering and who is not. Okay, 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. Okay, a little bit better. 11 people voted this time. Here's the answers. So C was the most popular answer, and let's take a look. Let's take a look. So it's asking me 2 things now. It's asking me what's the initial amount, the initial cost, as well as the rate. So again, we're looking for the correct percentage. Now, initial cost is right here. You don't have to look any further than that. The initial cost is right there. It's given to us. So those of you who chose A and B, I'm not really sure where you're getting that number. Where does 10,500 come from?
Subtracting something from something.
Yeah.
By 15,000.
Maybe, is that what you get when you do 15,000 times 0.7? Oh yeah, that is what happens. Okay. So yeah, you don't have to look any further, guys. It's right there. Well, that's our starting amount, point blank period. You don't have to do anything to that number. So A and B, immediately incorrect. Immediately incorrect. That should not even cross your mind. So between C and D now, I'm looking at the rate. And again, we're working our way backwards because I have 15,000 times 0.7 to the power of t. How do I know that this is a decay function and not a growth function?
Because
it's lower than 1.
exactly.
It's lower than 1. So I know that in order to get 0.7, I had to subtract from 1. And what number gets subtracted from 1 to give me 0.7?
30%, which is in decimal form, 0.3.
Good, 0.3. And 0.3 as a percentage is 30%. So that gives me answer choice C, which was the winning answer. So good job if you chose that one, because it's definitely a little bit trickier when you have a decay function, because with decay functions, you have to think about, okay, what number did I take away from 1 in order to get my answer? It's a little bit different. All right. So I have 3 practice problems on the board. I want you guys to work through each one on your own. We're going to take a good amount of time, about 10 minutes. Maybe a little bit less than that. Let's start with 5 minutes and just see how much we get in 5 minutes. So you do not need to write down all of the words onto your sheet of paper because I know it's a lot, but just for your purposes, this is problem number one, problem number two, and problem number three. So read them each carefully, answer them as best you can, and we'll meet back in 5 minutes. All right, that was 5 minutes. I'm gonna add just 2 minutes more because I don't want to go take too long on this. All right, time is just about up. So let's go ahead and go through these because I want to make sure everybody has enough time. So, number 1, 2.5%. What is that as a decimal?
0.025.
0.025. Good. 0.025. Now, am I growing or decaying?
Decaying.
How do you know?
Because it
Decrease.
It says decrease. Good. Decreased by 2.5%. So it's a decay function. So before I write my final, it's v of t, okay? V of t, what's my initial amount?
25,000.
25,000. So 25,000 parentheses 1 minus 0.025 to the power of t. What is 1 minus 0.025?
0.975.
0.975. You have to be very careful with that one. I saw a couple of incorrect responses. So this is 0.975. So my final answer, V of t equals 25,000, parentheses 0.975 to the power of t. What is the percent of decay?
2.5.
2.5%. Even though it says 0.975, my percent of decay is 2.5%. Okay, number 2, is it a growth function or a decay function?
A decay.
Decay.
Good. Other than looking at the words, what's another way you can tell right away?
Just lower than 1.
Less than 1, 0.98. What is the percent of decay?
2%.
2.
2%. Now, how'd
I
you get
got it
that?
wrong.
Because
You can subtract
what?
0.98 by 1, and then it's going to get 0.02, and then you
Turn
move
that
it to the
into
hundreds place.
percent. Good.
Oh, what I did, I added to see what gave 100.
Right. So there's a couple ways to do it, but either way, you're going backwards, right? You got to go backwards and figure out, okay, what number was taken from 1 to give you 0.98. So you can do, okay, what's 1 minus 0.98? That's 0.02. And 0.02 as a percentage is what gave me 2%.
I forgot that you have to, that when it's decay, you have to
Mm-hmm.
add it back.
Yeah,
That's why I added-
exactly. But now you're not going to make that same mistake, right? We're learning from it. That's very important because this is one of the things that most people get wrong even though it's not that hard at the end of the day, they just forget. So please, 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 with this type of question, make sure that you remember when you decay, you have to go backwards and figure out what was taken from one.
Do the opposite.
Yeah. Okay, last one. We have our function. What does the 85 represent? The 850 represent?
Well, at first I was going with A or D, but then I started to like realize more about 150. So it's A.
It is A. Remember, guys, that's your y-intercept. That's your initial amount. We don't touch that number. We don't do anything to that number. We don't do anything to that number unless you're plugging in an input. So when you see a function, you always know that's your initial amount, the amount of the initial deposit. It doesn't represent time. It doesn't represent the interest rate. It's just what he started with. Okay. So any questions on these three problems? Okay. Well, with that in mind, I know we don't have a ton of time left in class, but go ahead and get started on your Friday quiz. I just posted it onto period 2. There it is. All right, so get started on it. Work until class ends. If you don't finish it, that's okay. It's not due till midnight, so just don't forget to do it later today. What else is also due tonight at midnight?
The homework on Khan Academy.
The homework on Khan Academy. So hopefully you guys didn't leave it for today because that's going to be a lot to do tonight. But homework as well as quiz tonight at midnight. Make sure you get it done. Okay, so at this point, everyone should be going over to Teams to start the quiz. Don't leave until it's time to go. Just work silently on your own until I tell you class is over.